Hey guys, welcome to question MM317 of the Maths Methods Fortify study guide. So the rate of weight gain, W kilograms per month for a particular breed of dog T months after its birth can be modelled by dW dt equals AB e to the power of bt, where t is greater than or equal to 0, where a and b are real constants. So the information that we get is, at the instant a dog is born, it is growing at 9 on 4 kilograms per month. So that means that dW dt equals 9 on 4. 4 months after its birth, it is growing at 9/4e kilograms a month. Question A, or part A, says show that A equals -9 and B equals -1 on 4. Awesome. So A equals -9, B equals -1 on 4. Awesome. So how are we going to do this? Well, these two pieces of information are our things that we need to use. Okay. So when the dog is born, that means that time is equal to 0. Okay. So that's our first important part, and it's important to recognize this. So when t equals 0, dw dt equals 9/4. And 4 months after it's born, t is equal to 4, right? Because t is how many months after, t months after its birth, right? So when t equals 4, dw dt is equal to 9/4e. Sweet. So from here, we can use this to create simultaneous equations, right? So let's start with the first one. So we know that dw dt is equal to ab e to the bt. Okay, so from here that means that just using this first piece of information here, dw dt is 9 on 4 when t equals 0, right? So ab e to the power of 0, because b times 0 is just 0. E to the power of 0 is 1, so 9 on 4 equals ab, which means that a is equal to 9/4b. Cool. So this is our first simultaneous equation, right? So we've got a in terms of b, that's all good. And now we're going to use this other piece of information to find out what b is. So we know that dw dt is 9/4e when t equals 4, right? So we know ab e to the 4b, right? Because t is 4 and b is just b. But we know that a is equal to 9 on 4b, yeah? So we can substitute a into this value here. So 9/4b times b e 4b equals 9/4e. Awesome. Now this b and this b can actually cancel, right? Because we've got times b and then we're dividing by b. So these can cancel. So what happens is we get 9 on 4e to the 4b equals 9/4e. Cool. These 9 on 4s can actually cancel. So if we divide both sides by 9 on 4, we get 1/e equals e to the 4b, right? 1 on e is the same as e to the -1. Now if e to the -1 equals e to the 4b, that means that these two powers must be the same, right? Because these bases are the same. So therefore, -1 equals 4b. So therefore b equals -1 on 4. That's our first mark. So that's a lot of working for our first mark, but our second mark comes quite quickly after that. So, awesome. Now what? Now we need to find a. So we know that a is equal to 9/4b. We know our b value, so we can say therefore a is equal to 9/4 times -1 on 4, which is 9/1, which is -9. Second mark. So that's part A done. If you have any questions about the simultaneous equation stuff, or even just this rates stuff, chuck them in the comments below. But otherwise, let's move on to part B. Part B is also a 2-mark question, and it says, if a fully grown dog never weighs 10 kilograms or more, find an expression for W of t, the weight of a dog in kilograms, T months after its birth. All right, awesome. So before we were talking about rates, and now we're talking about the actual weight of the dog. Okay, so not how fast it's growing, but just what it weighs at any point in time. So we know that W of t is going to have to equal the integral of dw dt, right? Because this is essentially the derivative of our weight function, okay? Or dt, yeah. Awesome. So we know that dw dt is equal to, well, we know that it's this, but we also know that a is -9 and b is -1 on 4, like down here. Which means That's, we get 9 on 4 e to the negative 1 on 4 t. We're going to need to find the integral of this. Integrating this, we get this coefficient of t. We do 1 over that at the front of the equation, which means that we end up getting negative 9 e to the negative 1/4 t plus c, right? So we need that plus c at the end because we know that it needs to have a constant at the end, right? We always have to do that with antiderivatives like this. Now, if it never, so the part B says, if it never weighs 10 kilograms or more, find expression for W of t. So if it never gets to 10, then we must have an asymptote at W equals 10, right? So that means that our C value is 10. So that's actually our first mark there. So therefore, W of t is equal to negative 9e, negative 1 on 4t plus 10. And that's our final answer and our second mark for this part. Guys, that's part B done. Let's move on to part C. Part C is quite straightforward. It is a 1-mark question. And it says, how much does a dog weigh 9 months after its birth? Give your answer correct to 2 decimal places. Awesome. So we know that W of t, as found in our previous question, is equal to negative 9e to the negative 1 on 4t plus 10. And we're looking for its weight 9 months after. So W of 9. So negative 9e, negative 1 on 4 times 9 plus 10. Now, because this is only a 1-mark question, we can simply put this into our CAS. And what we'll get is 9.05 kilograms, which is 1 mark. That's our only mark. So this is our final answer for this question. Well, this part. If you have any questions, let me know, but let's move on to part D now. Now, part D tells us that Taylor has fenced off a play section for her dog named Yuki. The fence which borders Yuki's play area can be modeled by the x-axis, the line x equals 4, and the function f of x equals 10 log e of x plus 1 over x plus 1 squared. Now, Taylor wants to estimate the area that Yuki has to play in, so she approximates the area of the play section using the rectangles of width 1 meter as shown below. All dimensions are given in meters. Awesome. Part D says, find the approximate area of Yuki's play section according to the rectangles above, corrected 2 decimal places. Sweet. So we're going to need to find the area of each of these rectangles. So let's call them A1, A2, A3, and A4. Sweet. So, as always with these sort of approximation questions, we're going to say that the total approximate area is A1 plus A2 plus A3 plus A4. Now, we know that the rectangles are of width 1 meter. So we do, for each one of these, we have length times width, right? So 1 times our length, which is the y value of this function at that point, right? So at x equals 1, that's our y value of this rectangle here. So 1 times f of 1. Does that make sense? So we've got our f of x at x equals 1, that's the length of that rectangle. And then we have plus a2, which is again a width of 1, times the y value at that point, which is the length, which is f of 2. And I'm sure you can start seeing a pattern, so we'll have 1 times f of 3 here, plus 1 times f of 4. Fantastic. So, that's basically our first mark. Now you can sub in the values of x into this equation. I'm not going to do that now because I'm sure you can kind of see how that works. So we'll just have f of 1 is 10 log e of 1 plus 1 over 1 plus 1 squared, and so on. From that point, using CAS, so we do have our CAS in this question, approximate area is equal to 4.46 meters squared. Now, it's very important to use this meters squared because we know the dimensions are in meters, and we always have to give units when we're dealing with area. So that's our final answer for this question. Guys, that's it for part D. Let's move on to part E. The next section says, Alex, Taylor's sister, is more precise and would prefer to calculate the exact area of the play space. Alex does this by finding the integral of the function f of x. Cool. So our first bit, EI, is a 1-mark question. And it simply says, evaluate d of dx, or d on dx, of log e of x plus 1 over x plus 1. I don't really need those. Awesome. Now, this is a 1-mark question, so you can, of course, just chuck this into your calculator, or you can do the quotient rule because you've got a function divided by a function. I'm just going to chuck it in my CAS because that's going to be the quickest way, and there's no point doing it by hand if it's only a 1-mark question. So putting it into your CAS, you would get 1 take log e of x plus 1 all over x plus 1 squared. Sweet, that's it. So that's our first and only mark for this question, or for this part. Let's move on to part EII. Part EII is a 3-mark question. It is quite complex. This was a very difficult question. So EII, 3 marks. Now, this is an integration by recognition question, all right? So this is why it's difficult. A lot of students struggle with this, but let's work through it. So we need to find the exact total area of Yuki's play area. So the exact total area is going to be the area from 0 to 4 under the graph of f of x, okay? So our area is going to equal from 0 to 4 of 10 log e of x plus 1 over x plus 1 squared dx. That's going to give us our area. Now we could just put this in the CAS and get our answer, but because this is a 3-mark question, we actually do need to show a fair bit of working. So if you did that and just wrote the answer, you'd get 1 mark. You would miss out on the other 2. So you really need to show your understanding of how to do this. So going back to the previous question, we found that the derivative of log e of x plus 1 over x plus 1 was equal to 1 take log e of x plus 1 over x plus 1 squared. So let me just rewrite that actually so you can see what I'm doing. So we found that the derivative of log e of x plus 1 over x plus 1 was equal to 1 minus log e of x plus 1 over x plus 1 squared. Sweet. Now, so because of this, the derivative of this equals this, which is what we found, which means that the antiderivative of this is equal to this. Okay, so that's our important point of recognition here. So our antiderivative of 1 minus log e of x plus 1 over x plus 1 squared equals log e of x plus 1 over x plus 1. Awesome. This is actually our first mark. Okay, so it's quite generous in that sense, because you just need to recognize that that's what we need to do for this question. Now what we're going to do is we're actually going to separate this into 2 different integrals. Okay, so because we've got this numerator that has 2 different terms, we can actually split that into 2 different fractions. Okay, so we're actually going to get the integral of 1 over x plus 1 squared. So that's this bit here, 1 over x plus 1 squared, minus log e of x plus 1 over x plus 1 squared dx. And that's equal to log e of x plus 1 over x plus 1. Now, I'm sorry if you get bored with this working. It is a fairly long one, but you're just going to have to live with it. So, from here, we're going to separate this even further into 2 separate integrals. So we're going to say 1 over x plus 1 squared dx minus the integral of log e of x plus 1 over x plus 1 squared dx. And that's equal to log e of x plus 1 over x plus 1. Sweet. Now, let's go back up here. Alrighty. So, what we want is to get the integral of this, right? We want to get to that point. We can kind of see that this is going to get us there, but we're not quite there yet. So what we're going to do is we're actually going to, because we've got a negative in front of here, I'm going to move this to this side, and then I'm going to move that to this side, okay? So what I'm going to get is the antiderivative of 1 over x plus 1 squared dx minus this, so minus log e of x plus 1 over x plus 1 equals the integral of log e of x plus 1 over x plus 1 squared dx. Awesome. Now, I'm just going to flip these so that I can have this on the left side. So that means that the integral of log e of x plus 1 over x plus 1 squared dx is equal to, now the integral of 1 over x plus 1 squared is negative 1 over x plus 1. Now you're more than welcome to do that on your CAS, you don't need to do that by hand, but that's our answer, minus log e of x plus 1 over x plus 1. Fantastic. So we're actually almost at the point that we want to be. We want to find the area under this graph here, and we're almost there to finding the integral of this. but we're missing this 10 out the front. It's exactly the same apart from that. We've got our log e of x plus 1 over x plus 1 squared, which is the same as this, but we need this 10 here. So what are we going to do? We're going to put it there. We're going to put our 10 there. 10 log e of x plus 1 over x plus 1 squared dx. But if we add a 10 to this side, which means that we're multiplying this side by 10, what do we have to do this side? Also multiply by 10. So we get 10 times this whole side, negative 1 over x plus 1 minus log e of x plus 1 over x plus 1. And that's our integral right there. So we've just found the integral of 10 log e of x plus 1 over x plus 1 squared, which is exactly what we wanted here. So that means that the integral from 0 to 4, actually this, no, the next step will be a second mark. So from 0 to 4 of 10 log e of x plus 1 squared dx is equal to 10 negative 1 over x plus 1 minus log e of x plus 1 from 0 to 4. That's it. So this is going to be our second mark right here. And now all we have to do is just sub in our values of 4 and our values of 0 as well. Okay? So what we end up with is, how am I going to do this? Alrighty, so what we're going to get is, actually, you know what? I'm going to merge these together. So let me just rewrite this. So this is equal to negative 10, 1 plus log e of x plus 1 over x plus 1 from 0 to 4. Exactly the same thing, okay? I'm just doing this because that's the way I've written it in the work solutions. You could do this pretty much infinitely many ways in terms of the working that you're going to do, but this is the way I'm going to show you just because I've written it that way in the solutions. So now again, we just have to evaluate this. So what we end up getting is negative 10 outside of 1 plus log e of 4 plus 1, which is 5, all over x plus 1, so 4 plus 1, which is 5, and then we're going to minus negative 10 outside of 1 plus log e of 0 plus 1, which is just 1, all over 0 plus 1, which is 1, right? Now, this pretty much simplifies to negative 10, take 10 log e of 5 over 5 plus 10, which simplifies to negative 2 minus 2 log e of 5 plus 10. So what we end up with is 8 minus 2 log e of 5. And then we can actually take a common factor of 2 out and say 2, that's 4 take log e of 5 meters squared. And this is our third and final mark for this part. So that's part E done. If you have any questions about this, I know that was confusing, just hit me up in the comments below, but let's move on to part F for now. Part F starts taking us through the difference between Alex and Taylor's answers, right? So we have part F. It's 1 mark question, so you don't have to do any working, you just have to show the answer. So it says Taylor's approximation is k% less than the actual area that Alex has calculated in part EII. Find the value of k correct to 2 decimal places. Awesome. So we know that Taylor's approximation was 4.46, right? We found that in an earlier part, and we know that Alex was 2 times 4 take log e of 5, right? We know that now. So in order to find the percentage that Taylor is of Alex, so Taylor's less than Alex, as the question says, and to find the percentage, we just do this divided by this and then multiply by 100. So our percentage is equal to 4.46 divided by 2 times 4 take log e of 5, and that is equal to 0.9336, which means that the percentage is 93.36%, okay? So Taylor's approximation is 93.36% of Alex's, which means that the difference between this and 100 is how much less it is, which is the value of k that we're looking for. So therefore 100 take 93.36 is equal to k, which is equal to 6.64. It's our first and only mark for this question. That's it for part F. If you have any questions about that or any of the other parts in this question, please hit me up. That's it for MM317. Have a great day, and I'll see you in the next video.